Let's do question number 8. Question number 8 is on polynomials, remainder theorem, factor theorem, and identities, and also solving cubic equation. So let's do 8a first. So 8a, the expression fx equals to ax cubed plus a minus 3b bracket times x squared plus 3bx plus c is exactly divisible by x squared plus 3x. When fx is divided by x plus 2, the remainder is 10. Find the values of a, b, and c, hence factorize fx completely. So the first thing to take note is that the x squared plus 3x over here, I can factorize it as x bracket x plus 3, right? So this means that since it says that this fx is exactly divisible by x squared plus 3x, this means whatever that makes it 0 is x equals to 0. Whatever that makes this 0 is x equals to minus 3. Okay, so that means we can use factor theorem, f of 0. Okay, so f of 0, meaning I'm going to substitute all the x at 0. So all of this is gone because I substitute x equals to 0. So f of 0 equals to c, which means that c is equals to 0 because factor theorem. This is a factor, okay? As mentioned earlier, x squared plus 3x is a factor of fx. And we have already factorized x squared plus 3x into these two over here, which means that f of 0 is going to give a value equals to 0 because x squared plus 3x is a factor of fx. Okay? Similarly, we can also deduce that using this value over here, f of minus 3, right, is equals to 0 as well. So then I'm going to substitute minus 3 into all the x over here. We get minus 27a plus 9 bracket a minus 3b minus 9b. Okay, now we don't need to write the c anymore because earlier we have found out that the c is equals to 0. So this is equals to 0. So minus 18a minus 36b equals to 0. Right, so simplifying this, we can see that a is equals to minus 2b. So let's call this equation 1. Okay, so next, the statement in the question tells us when fx is divided by x plus 2, the remainder is 10. So what makes x plus 2 0? X equals to minus 2. So what I'm going to do is I'm going to substitute minus 2 into the function of fx. Okay, now this is equals to 10, right? Using the remainder theorem. So now I'm going to substitute minus 2 in here, here, and here. Okay, into all the x. So this gives us, let's see, minus 8a plus 4, a minus 3b minus 6b. Right, again, c is equals to 0. We know that already. This is equals to 10. Okay, simplifying, we get that minus 4a minus 18b equals to 10. So this is equation 2. So what I'm going to do over here, okay, because there's no space, I'm going to write it here. I'm going to sub x equals to, I'm going to sub equation 1 into equation 2, right? This means that we have 8b minus 18b equals to 10, which means that b is equals to minus 1. Now, because b is equals to minus 1, then sub b equals to minus 1 into equation 1, we get that a is equals to 2. So now we have our a and our b and our c. Let's put it all back in. We can see that fx is actually equals to 2x cubed plus, so a minus 3b, in this case, it will be 5. So it will be 2x cubed plus 5x squared. 3bx will be minus 3x, and c is equals to 0. So this will be our fx after substituting all the values of a, b, and c, right? So now I'm going to take out x over here. So we get 2x squared plus 5x minus 3. And I'm going to factorize 2x squared plus 5x minus 3, which means that this is equals to x plus 3, 2x minus 1. Let me check if it's correct. Yes, it is correct. So there we go. We are done with 8a over here. Okay, so let's do 8b over here. This is a question of identities. It says that this polynomial over here is equals to this expression over here. So what you do generally when you see this type of question in the exam is to try to make all the linear factor over here 0. Okay, try to make this 0 by substituting suitable values of x. Okay, try to make this 0, try to make this 0, try to make this 0, try to make this 0 by substituting suitable values of x. Okay, exhaust all of these possible ways to make all of this 0 so that you can get the values of a, b, c, and d. Okay, now once you have exhaust making all the linear factors 0, right, then you move on to compare the coefficient of the terms if needed. So here what I'm going to do is I'm going to substitute x equals to 1, okay, which means that this is gone, right? Same for this as well. Okay, then I get that d equals to, so substituting x equals to 1 over here as well, it will be 3 minus 2 plus 1 minus 4, which means that d equals to minus 2. Okay, so next, let's substitute x equals to minus 1, which means that this is gone, okay, because just in case for certain students you might not understand, minus 1, if you substitute into x squared, right, it will be minus 1 whole thing square, that will be 1, and 1 minus 1 is 0, right? So this thing is 0, so this is gone. Same thing, minus 1, substitute over here into x, minus 1 plus 1 is 0, so this is also gone, right? And we know what's our d is minus 2, right? And minus 1 substitute over here, it will be minus 1 will be minus 2 times a is minus 2a. Okay, so we have minus 2a minus 2. This is the right hand side that I have evaluated earlier, right? So now substitute minus 1 into the left hand side, we get minus 3 minus 2 minus 1 minus 4, which means that minus 2a is actually equals to, let's evaluate this, this is minus 10, minus 8, right? Which means a is equals to 4. Okay, so now we have our a and our d, we need to find our b and our c. Okay, so we have actually exhausted all the options to make all the linear factors zeros. So the next thing that we have to do over here is to actually try another way. Okay, so here I'm going to substitute x equals to 0. So when x equals to 0, right, so this means that so just in case, for the sake of clarity, this a is 4, which is what we have found earlier, and this d over here is actually minus 2, which is also what we have found earlier. So now I'm going to substitute x equals to 0. So this is gone, this is gone, this is gone. So we have our minus 4 on the left hand side. Okay, so 0 minus 1 is minus 1, and minus 1 times 4 is minus 4. Okay, so here I'm going to substitute 0, 0, which means I'm left with minus 1 times 1. That will be minus 1 times b, so minus b. Okay, and here we substitute x equals to 0. So here you can see this x over here. Since I substituted x equals to 0, this whole thing is gone. And then I'm left with my d over here, which is minus 2. So this implies that b is actually equals to minus 2. Okay, so now let's write the value of b here. So we have our b has minus 2 over here. So now we are left to find c over here. So for c over here, you can substitute any values of x, right? Because we have our a we have our B, we have our D. So now our job is to find C. That's the only unknown that we don't know. And since we have our A, our B, and our D, we can just, for this final step, substitute any values of X. But I would suggest that you substitute a simple value. Don't choose too high. Okay, just substitute X equals to 2 will do. Don't substitute values like X equals to -4, -3, or 3 or 4. Okay, don't make your life difficult. Choose an easier value of X. So let's choose X equals to 2. So when X equals to 2, okay, so X cubed, so 2 cubed is 8, 8 times 3, 24, and 2 square, 4, 4 times -2, -8, and plus 2 minus 4. Okay, so A is 4, right? So 2 minus 1, 1. 1 times A is A. What is A? A is 4. So it's just 4 over here. And 2 minus 1 is 1. 2 plus 1 is 3. So 3 times 1 is 3. 3 times -2 is -6. And so this 2 square is 4. 4 minus 1 is 3. 3 times 2 over here is 6. So we have 6C over here. And finally, D is -2. Okay, so this implies that we have, let's evaluate the left hand side. It will be 24 minus 8, 16. 16 plus 2, 18. 18 minus 4 is 14. And the right hand side is 4 minus 6 minus 2. That gives us -4. Right, -4 plus 6C. So this means that C is actually equals to 3. And we are done with question 8B. We have finally solved the values of A, B, C, and D. So my advice for this question, right, okay, let me emphasize again, is to first, you try to make the linear factor over here has 0 by substituting in a suitable values of X. Okay, once you have exhausted all the options of making all the linear factors 0, okay, that's when you just simply substitute any values of X and then you find the last unknown. Or sometimes it could be you are required to substitute any values of X. So in another example, you are required to substitute any values of X, but 2 of them, okay, to solve for a simultaneous equation involving 2 unknowns. Okay, so that is basically it for question 8B. I would say that more exposure to this question will be better for you. But at the end of the day, let me emphasize this again. Your first thing that you should do, okay, for this type of question, even if you do not know how to do or you're stuck, is to try to substitute. Again, I emphasize, try to substitute suitable values of X to make all the linear factors 0. Okay, that will allow you to evaluate and obtain some of the values of the unknown that the questions is asking you for.